The fascinating life of carpenter bees, from solitary nesters to essential pollinatorisk parent bees Xylocopus pp, are among nature's most intriguing insects, blending solitary behavior with occasional social cooperation while playing a vital role in pollination. Unlike honeybees or bumblebees, carpenter bees carve their homes into wood, creating elaborate tunnels for their offspring. Their life cycle, nesting habits, and ecological significance reveal a story of adaptation, survival, and sometimes conflict with humans. Below is a detailed exploration of their unique life cycle, behavior, and ecological impact. 1. Physical characteristics and identification. Carpenter bees are often mistaken for bumblebees due to their similar size and coloration. However, key differences set them apart. Shiny, hairless abdomens. Unlike bumblebees, whose abdomens are fully covered in fuzzy hair, carpenter bees have smooth, glossy black abdomens. 59. Sexual dimorphism. Males have white or yellow facial markings, while females have entirely black faces. Males also lack stingers, though they aggressively defend territories by dive-bombing intruders. 210 size. They are large, typically 0.75–1 inch long, with robust bodies adapted for burrowing into wood. 7. These traits make them easily recognizable once observed closely, though their resemblance to bumblebees often leads to misidentification. 2. Life cycle. From egg to adult carpenter bee's life cycle is a marvel of solitary insect development, divided into 4 key stages: a spring emergence and mating in early spring April-May. Adult carpenter bees emerge from overwintering in their natal nests. These bees, now sexually mature, immediately seek mates. Males establish territories near nesting sites, hovering aggressively to ward off rivals and attract females. 110. After mating, females begin the laborious task of nest construction, while males die shortly after fulfilling their reproductive role. 7. Beat nest construction and egg-laying. Female carpenter bee is the sole architect of the nest. Using her powerful mandibles, she bores a perfectly round entrance hole about inch in diameter into untreated wood, often selecting cedar, pine, or redwood. 19. The tunnel extends 1–2 inches straight in before making a 90-degree turn to follow the wood grain, creating a gallery 4–12 inches long. 710. Inside the gallery, the female crafts individual brood cells. Each cell is provisioned with a pollen ball made of nectar and pollen, serving as food for the developing larva. 8. A single egg is laid atop each pollen mass, and the cell is sealed with chewed wood pulp. 1. A female may create 6–10 cells per gallery, with each gallery reused and expanded over successive generations. 10. See larval development and pupation. The eggs hatch into larvae within a week, feeding on the stored pollen. Over 5–7 weeks, they progress through larval and pupal stages, undergoing complete metamorphosis. 79. By late summer August–September, new adults emerge, chewing through the cell partitions to exit the nest. 8. Overwintering, and the cycle repeats. Newly emerged adults feed on nectar to build energy reserves before returning to their natal galleries or nearby tunnels to hibernate through winter. 110. Come spring, the cycle begins anew. 3. Social behavior. Solitary but occasionally cooperative hill carpenter bees are primarily solitary. Recent research reveals nuanced social behaviors. Solitary nesting. Most females operate independently, building and provisioning their own nests. 7. Social nesting. In resource-scarce environments, multiple females often related may share a nest. One female acts as the primary egg layer and forager, while others guard the nest. 510. Nest inheritance. Subordinate females may inherit nests after the primary queen dies, extending their lifespan to 2 to 3 years compared to the solitary female's 1-year life. 5. This flexibility in social structure enhances their survival in varying environmental conditions. 4. Ecological role. Pollinators with a dark-sided carpenter bees are vital pollinators but also pose challenges. Pollination benefits. They are effective pollinators for open-faced flowers, for example passion flowers, salvias, and crops like tomatoes and eggplants. 510. Some species practice nectar robbing, piercing flower bases to access nectar without pollinating, though they still contribute to pollination in other plants. 4. Bee structural damage. Repeated nesting in wooden structures, for example decks, eaves, can weaken wood over time, especially when galleries exceed 10 feet in length. 17. Secondary damage occurs when woodpeckers drill into wood to feed on bee larvae. 10.5. Human interactions, prevention and coexistence. To mitigate conflicts with carpenter bees, consider these strategies. Preventative measures: paint or stain wood surfaces, as bees prefer untreated wood to 110. Alternative nesting sites: provide untreated pine blocks away from structures to divert bees. 5. Non-lethal control: seal active nests after treating with insecticidal dust applied by professionals. 710. Conclusion: carpenter bees exemplify nature's balance between ecological benefit and human nuisance. Their intricate life cycle, from solitary nesters to occasional social cooperators, underscores their adaptability. While their wood-boring habits can be destructive, their role as pollinators is irreplaceable. By understanding their behavior, we can foster coexistence, protecting both our homes and these remarkable insects. For further reading, explore the detailed sources cited throughout this article.